Hi, my name is Milecia, and I'm a developer advocate here at Iterative. So today I want to talk to you a little bit about hyperparameter tuning with DVC Experiments. So with DVC, you're actually able to automate your hyperparameter tuning if you're using something like grid search or random search. And that's what we'll be going through today, is just a quick demo of how to do that with DVC. So the first thing you'll need is a machine learning project, and then you'll have to set up the DVC pipeline, which you can find a lot more information about in our docs. But what I want to show you today is how you would actually do this with DVC. So I'm going to start with my grid search script right here. And as you can see, just like with most grid searches, we have a range of values for the two hyperparameters we'll be tuning. And of course, this is probably going to be a lot more in a real machine learning example, but just for this quick demo, we have these few values for these couple of hyperparameters. But the main thing we're doing is creating these sub-processes that make DVC experiment queues for us. So these queues give us the ability to create experiments, but not run them as soon as we create them. So if you wanted to offload some of these experiments to different machines, or you wanted to run some in the cloud, or you just want to run batches of these experiments, you can do that with the DVC queue feature. So before we actually run this, it would probably help if you saw how a DVC experiment works in the first place. So to run an experiment in DVC, you'll have your hyperparameters defined like we have here. And I'm going to change this value to 510. And then down in my terminal, I'm just going to run DVC exp run. And you'll notice that this starts our training script and it gives us some results. So once that training step is finished, we can take a look at the results by running DVC exp show. And it'll bring up this table with all of the hyperparameters that we used. It'll bring up the metrics that we're recording. Like in this example, we're recording the average precision and that rock AUC value. And if I tab over a little bit, you can see how our hyperparameter changed here. So that's just a quick intro to DVC experiments. So now that you've seen how an experiment works, let me show you how it would work if you did this with a queue. So to queue an experiment, you just run the command DVC exp run with the queue flag, and then you can use this set param option to update any of the hyperparameters that you want. So in this case, for this queue, I'm going to update the min split to 67. And you'll see that this experiment was queued. And if you want to check on any experiments that you have in your queue and see what those hyperparameter values are before you decide to run everything, you can take a look at this table again. And any experiment with an asterisk next to it means that it's queued. And if I tab over again, you can see our updated min split hyperparameter there. Alright, so now that you have a really quick background on DVC experiments and queues, let's go ahead and run this grid search. So you'll notice I'm already in a virtual environment. I know that always catches me, so want to make sure that you do note you need to be in a virtual environment. And we'll just execute this script like we would any other Python script. Well, let me make sure I get the right directory. That would probably help. So this is in the source directory, and now it'll run this script and queue up an experiment for every combination of these hyperparameter values. So since we're running a grid search, this is going to do an exhaustive search over all of the values that we've given for these two hyperparameters. So what's going to happen is there will be an experiment queued for each combination of this NEST value matched with this min split value. And as you can see, it's queuing quite a few experiments. So that is one thing with grid search, is that since it is a very exhaustive search, sometimes it can take a little bit more time than something like a random search. But now all of our queues are finished. Well, we're done making them. I'll clear the terminal out, and I want to show you what the table looks like now. So you see we have a lot more experiments here, but that's fine, because since they're all queued up and ready to go, I'll clear the terminal again. We'll run DVC exp run, and we'll use the -- run all flag. And what this does, it goes through and checks for any queued experiments, and then it's just going to run all of those. So in this case, we're running everything in series, which is fine because this shouldn't take too long for training. But if you have a more complex model where a training step takes hours or maybe even a day, you might want to run those in parallel, which you do have the ability to do with DVC if you use our jobs option. So you can run 2 experiments in parallel, 3 in parallel, however many you want in parallel. But what's happening right now is that it's going through and executing the training and evaluation steps for each of those queues that we did. So it has finished running all of our queues. If I clear the terminal and bring up our table again, this time I'm going to add a few more options so that the table is clearer for us to see which hyperparameters got updated. So I'm going to include the train.nest and train.minSplit. And now you see this table is a little bit easier to read, but we have all of those queued experiments. So you can tell by the values we have here that we went through every combination of those values for the NEST and minSplit for this. And it shows you what our average precision and our ROC AUC curve is. So that is how simple it is to implement a grid search with DVC. You just have to write a little script, include the values that you want, and run it. So to wrap up really quick, we did a very similar thing here with random search, where we have a number of experiments. I'm going to limit this to 10, and there's random values for each of those hyperparameters, and then we run our queue. So to execute this random search, I'm just going to run this random search.py script. And this is going to queue up experiments with random values for both that NEST hyperparameter and the minSplit. So as these experiments queue up, hopefully you can see that DVC handles this stuff pretty easily. So I'm going to show that table one more time, but I'm going to show the cleaner one so that we can see those random hyperparameter values, because maybe you want to check what those values are before you actually start running all of these queued experiments. So you see what they are. We can go ahead and clear the terminal, and I'll run DVC exp run. I'll use the run all option, and this will execute those 10 experiments. The reason that we use random search over grid search is because for the same amount of time, we can usually get comparable or even better results for our model than we get with grid search. So it takes less time, less resources, and it gives us better models. So now that we've run the queues for our random search, let's take a look at that table again. Now I'll make the terminal a touch bigger. And you can see where the random experiments start and end, and down further you can see where we have our grid search experiments. So there's a few values in here, like this average precision is 55%, and down here you see we got something similar, but it took less runs with the random search to get a similar average precision. Now that you've seen how we do grid search and random search in DVC, I hope that you'll head over to the docs and look up more information about how to execute parallel jobs with queues. So hopefully this was useful.